This is Dr. Holt. I want to talk about how to solve a problem like this one. You have A plus KB plus C plus ND is equal to 0. In this case, we're adding these four vectors together. We know the summation is going to be 0, but we don't know what K is and we don't know what N is. And these are just variables. Some value we're going to be multiplying by B, and some value we're going to be multiplying by D. I'm going to work through how to solve this problem. We're going to determine what the value of K is and what the value of N is. Now, since the summation is going to be 0, we can immediately say that if I sum or add all the forces in the x direction, they must equal to 0. And we can say if we sum all the forces in the y direction, they must also equal to 0. This being our x, and this being our y direction. So to the problem very similar to what we did before, we're going to sum up the forces in the x direction. And again, we'll set them equal to 0. So we'll start with A. A is going to be 60 times the cosine of 43 degrees. We jump to B. Now B is going to have a negative x component, so it'll be minus, and we're going to go ahead and put our variable here, K, in front, times 50 times the cosine of 35 plus C, and that would be minus 2, 20 times the cosine of 44. I got parentheses a little better. 44, and now D is going to be multiplied by N. It's going to have a positive x, so it'll be plus N times 30 times the cosine of 55 degrees. Okay, and we're going to try to simplify this. We'll get our calculator out, and we're going to see what we're going to get here. We'll go ahead and add this value and this value together because it has no variable in front like the K or the N. So 60 times the cosine of 43 minus 20 times the cosine of 44. That's going to give me a value here of 29.49 minus, and we'll go ahead and get the value in front of the K, 50 times the cosine of 35. So that gives me minus 40.96K. And then we're going to go ahead and do this part right here. 30 times the cosine of 55 gives me 17.21. Times N. Okay, so again, here are my two unknowns. We still don't know. And this will be my equation number 1. Okay, so let me scroll up to give myself a little bit more space. Now we're going to go ahead and do the y. And again, we know the summation of the forces in the y direction must equal to 0. We start with a 60. 60 times the sine of 43 degrees. And then B is B plus K times 50 times the sine of 35. And then we're going to go minus 20 sine 44. And then we're going to do minus N times 30 times the sine of 55. I'll go ahead and put the parentheses in. You don't have to do this, but just to clarify that those are angles. Alright, and now we're going to go ahead and add and run the numbers. We're going to add this one and this one together, or if you want to say subtract one from the other. So 60 times the sine of 43 degrees minus 20 times the sine of 44. That's going to give me a value of 27.03. And then we're going to do the K. 50 times the sine of 35 gives me plus 28.68K. Just go and put a circle around that so we know it's a variable. And now we're going to do this one, 30 times the sine of 55. So 30 times the sine 55. And again, that's going to be minus 24.57, and that's going to be n. Alright, so those are my two equations. I got two equations, I got two unknowns, so we know we can solve for these. Now there's a couple ways we can solve for these. We could solve for these by substitution, we could do elimination, or we could set up a matrices. I'm going to go ahead and do substitution. So I'm going to take this equation here, bring it down here, and we're going to solve for one unknown. So I'm going to move everything to one side except for, let's do n in this case. I'm going to rewrite this as 17.21n is going to equal to, and now again we know that the summation of these equals 0, so I'll move everything to the other side. That would be minus 29.49 plus 40.96k. I'm going to divide everything by 17.21. So 29.49 divided by 17.21 gives me a 1.71 value here, and that would be negative. We come over here, 40.96 divided by 17.21 gives me 2.38k. Again, scroll down a little bit more, and now what you want to do, you want to substitute that back in. Now you cannot substitute it back into this equation because that's what you use to solve for n in this case. We're going to substitute it back into this one. So we're going to say that 27.03 plus 28.68k minus 24.57, and now instead of using n, we're going to put in what we know n is equal to, 1.71 plus 2.38k. And now we know that's equal to 0, right? Because we already said the summation of all forces had to be 0 in the x and y direction. Now you notice you only have one unknown. You have a k here and a k here. Go ahead and distribute the 24.57. Let's go ahead and rewrite this. That's going to give me 27.03 plus 28.68k. Now we'll go ahead and do this. So minus 24.57 times a minus 1.71 gives me plus 42.01, and then minus 24.57 times 2.38 gives me a value of minus 58.48k. Again, we're going to be off a little bit with rounding, but close enough. Now we add our two k's together. We're going to add this one and this one together. Do that again. So 58.48. Okay, so that's going to, on this side, that's going to give you a minus 29.8k. We'll go ahead and add this one and this one together. We're going to move it to the other side. So 27.03 plus 42.01. Again, we move it to the other side, it becomes negative negative 69.04. Now all we have to do is divide everything by negative 29.8. And we get our value immediately with k is equal to 2.32. Now we got a value of k. Now it's very easy to get the value of n because we know this equation right here, and all we have to do is substitute back in for k. So we know n is going to equal to negative 1.71 plus 2.38 times 2.32. Let's see what that gives us. Negative 1.71 plus 2.38 times 2.32. That gives us a value of n of 3.812. Again, this is rounding a little bit different here, but again, we got 2 places to the right of decimal here, and you could make this 3.81. It's going to be close enough. So that's how you get the two variables. That's the value of getting the value, that's how you get the value of k, and that's how you get the value of n. Alright, again, follow this approach, set each force, the summation of all forces equal to 0, and then solve for your unknowns. You'll get 2 equations, 2 unknowns. You can substitute one of the equations back into the other for one of the variables, and then you can solve for one of the variables, and then use like the other equation to put this value back in to find out what the second variable is going to be. Alright, again, best of luck with this.